welcome to section 10.3, probability. Okay, so what we're going to do, our first objective is define probability and design probability models. Then we're going to write teacher solutions to probability problems. Okay, so we have to first talk about the two types of probability. We've got experimental and we've got theoretical. So suppose that you have a coin and a dice in your hands. Okay, you're going to roll the coin and then roll the dice, and then what you're going to do is you're going to record what you get in the following chart. You're going to do this 12 times. Did you roll everything possible? What are all the possibilities, and what possibilities did you not roll, if any? So we're not going to do the experimental part, but the experimental part is what you actually do. It's actually what happens, and it's going to be different every time you do it. Okay, theoretical is what is supposed to happen. So if I roll my coin, I could roll a heads. And if I roll a dice, I could roll a 1. I could flip a heads and roll a 2. I could flip a heads and roll a 3. I could flip a heads and roll a 4. I could flip a heads and roll a 5, and so on and so forth. So what I'm doing here is I am writing down all of the possibilities that I have. And this is telling me that I have a total of 12 possibilities. It's not telling me what actually happens, it's telling me what should happen in a perfect world, and we don't live in a perfect world. Okay, so let's look at something else. So what is probability? Probability is basically how you find it is saying, hey, what I want divided by my total possibilities. Okay, so suppose that I'm flipping ahead. So let's actually flip this. This is start, stop. It's fun. So the probability of flipping a heads is, hey, it's a two-sided coin. I could flip a heads or a tails. So what I want is a heads, so I can get 1. And I have 2 sides, so it's 1/2, or in other words, 0.5, or in other words, 50%. We're used to seeing probability written as percentages, but what we're going to actually do is write in terms of fractions most of the time. Okay, let's go through some more examples here. So we got to talk about all of our possibilities. So how can we write down all of our possibilities? So what we do is we write sample spaces. So what we want to do here is write a sample space of all the possible outcomes for the spinners if each is spun once. Okay, so I could just make a list. Okay, I could say, hey, I can roll an A. So this is kind of fun. It actually spins. They both spin. Okay, so I could spin an A and I could get a 1. I could spin an A and I could get a 2. I could spin an A and I can get a 3. Spin an A and get a 4. All right, that deals with the A's. So I could also spin a B and then spin a 1. I could spin a B and spin a 2. Spin a B and get a 3. Spin a B and get a 4. Or I could spin a C on the first spinner and get a 1, a 2, a 3, and a 4. Right? So those are all of my possibilities. We could make this harder. We could put 3 things in there. We could say 2 spinners and a coin. Then you'd have to write down all of the possibilities there. Okay, writing out a list gets kind of tricky at times. So sometimes we can come up with probability models. Our first probability model is an area model. This deals with 2 independent events. So I'm going to write that in there so that we remember this. 2 independent events. Okay, what does that mean? These spinners that I have up here are independent of each other. The second spinner doesn't matter what happened on the first spinner like it does for the second spinner. But let's say that I have marbles in a bag and I have blue ones and red ones. If I pull out a blue marble and throw it away, then if I put my hand in that bag a second time, it does depend on what happened the first time. Those are dependent events. These are independent. Okay, so these are our easiest ones to deal with. Independent. Basically, they don't depend on each other. Don't depend on each other. Right? So let's draw a probability model that represents all the possible outcomes for the previous spinners if each is spun once. Okay, so what we're going to do, an area model is simply just a rectangle with all the pieces. So my first spinner, I could spin an A, a B, and a C, I believe. Yep. My second spinner, I could spin a 1, a 2, a 3, and a 4. So all I'm doing is I'm organizing my information into this nice organized list here to a box. And it'll look like this. And here I have A1, A2, A3, and A4. B1, B2, B3, and B4. C1, C2, C3, and C4. Okay? So since this is an area model, and it's a rectangle, that's why we only can have 2 events. Okay? So let's look at something a little bit different. Now let's look at teacher solutions. And let's also talk about not only independent events, but we're going to also talk about dependent events. All right, so here's a teacher solution include a probability model with labels and should be organized in a way that makes the reasoning clear to students that you are teaching it to. So what we're going to do is we're going to talk about what we mean with replacement. Okay, so I'll explain that here in a second. So suppose I have 2 letters are drawn at random, and that's supposed to be from the word school. If they are drawn one at a time with replacement, what is the probability that they are the same letter? Write a teacher solution. Okay, so think of it this way. I have school, and they're all separate letters. Suppose that I put my hand in the bag and I draw an S. Okay, so I'm going to record that I'm going to draw an S. Then I'm going to take that S and put it back into the bag. If I put it back into the bag, I didn't change anything. The S is still going to be there so that I could pull it out a second time. So when we have with replacement, this means that they are independent events. So let's draw an area model showing that. Let's let my first draw of school be right here. Okay, this is going to represent my second draw. And I could draw an S, I could draw a C, I could draw an H, an O, or an L. So I'm drawing my area model, just like what I did with the spinners. Boy, I don't know if I'm going to give myself enough room, but we'll squeeze it in there. Okay, so I could draw an S and an S, and S and a C, S and a H, S and a O, S and a O, S and a L. I could draw a C and a S, a C and a C, a C and a H, a C and a O, a C and a O, and a C and a L. H and a S, an H and a C, an H and a H, an H and a O, an H and a O, and an H and a L. An O and a S, O and a C, an O and an H, an O and an O, an O and an O, O and an L. OS, OC, OH, OO, OO, OL, and LS, LC, LH, LO, LO, and an L and an L. All of my possibilities. So if I draw an S the first time in the first draw, can I draw it the second time? Yes. So and the reason I can is because we put it back in there. So now what we're looking at is what is the probability that all of them are the same letter. So we're looking for the probability of the same letter. So all I'm going to do is I'm going to circle everything that has the same letter. And if you notice, we go diagonal, that's one of them, but then we got to look at the other letters. And I think that's it. Okay, so that's 8 of them. And all the total possibilities, 1, 2, 3, 4, 5, 6. 6 times 6 is 36. So we reduce that and we have 2/9. Okay, that's the area model. There is an equation. I'm going to show it to you. If you understand it, awesome. If not, you can always use the area model. Okay, so the probability of the same is going to equal the probability of an S and an S plus the probability of getting a C and a C plus the probability of getting an H and an H plus the probability of getting a O and an O plus the probability of getting an L and an L. Now, why did I only write the O's one time? Because this equation puts all the O's into one basket, whereas the area model separates the first O from the second O. Okay, so it's kind of like two different things, whereas with the equation, O's are O's, regardless of if it's the first O or the second O. Okay, so if I look at the probability of getting an S and an S. Well, this is how we find that. The probability of getting an S the first time is 1/6. Now, if I put that S back, the probability of getting an S the second time is still 1/6. So I multiply those together. Now I look at the probability of getting a C and a C. Well, the first time is 1/6. The second time is 1/6. We do the H's. The H's work the same way. The probability of getting, well, let's just go down here to make sure that we're looking at the right thing. The H is still 1/6. Okay, so that was the H's. Let's deal with the O's. Now I have two O's, so the probability is getting 2/6 times 2/6 plus probability of an L is 1/6 times 1/6. All right, we add all those together, and that's 1/36 plus 1/36 plus 1/36 plus 4/36 plus 1/36. 1 plus 1 plus 1 plus 4 plus 1, so that's 3, 7, 8. There's our 8/36. And that reduces down to 2/9. Okay, in the next video, I'm going to show you how to find it when we are not putting the letters back and they become a dependent event. Thanks.